Hey everyone! Today we're breaking down chemical bonding, the thing that keeps the world from falling apart. Literally. Atoms are made up of three subatomic particles: protons, neutrons, and electrons. Electrons orbit the nucleus of the atom in energy levels. Among these electrons, the ones in the outermost level are called valence electrons. Valence electrons play a crucial role in chemistry because they determine how an atom interacts with others. Think of them as connectors to allow atoms to bond and form molecules. To visualize valence electrons, you can use Lewis dot structures. These diagrams represent an atom's valence electrons as dots around its chemical symbol. More on that later. What we have here is the periodic table. The periodic table currently has 118 elements. Now, elements in the periodic table aren't just put in there randomly. If we zoom into hydrogen here, we can see that the atomic number is equivalent to the number of protons an atom has. Now that we know the way atoms are placed in the periodic table, we can figure out some different periodic trends. The five main ones we'll focus on are atomic size, ionization energy, electronegativity, and the size of cations and anions. Atomic size increases as you go down and left of the periodic table. Ionization energy and electronegativity both increase the more you go up and to the right of the periodic table. Lastly, cation and anion size decrease as you go to the right of the periodic table. Ionic bonding happens when atoms decide to transfer electrons to become more stable. This is a sodium atom. Metals like sodium are happy to give up extra electrons. This is a chlorine atom. Nonmetals like chlorine can't wait to take electrons. When sodium and chlorine form an ionic bond, sodium becomes a cation because it loses an electron, making it positively charged. And chlorine becomes an anion because it gains an electron, making it negatively charged. When a sodium atom and a chlorine atom form an ionic bond, they make an ionic compound called sodium chloride, also known as table salt. The physical properties of ionic compounds are high melting point and boiling point, high solubility in H2O, high conductivity, and it's mostly found as a solid. Unlike ionic bonds, where electrons are transferred, covalent bonds happen when atoms share electrons. A covalent bond can have up to 3 bonds, with each bond containing 2 shared electrons. Single bonds are the weakest and triple bonds are the strongest. There can also be 2 types of covalent bonds, polar and nonpolar. In polar covalent bonds, electrons are shared unequally. For example, in water, oxygen has a stronger pull on electrons, creating partial charges. Nonpolar covalent bonds, on the other hand, share electrons equally, like this oxygen molecule. Now let's look at hydrogen bonds. These are weak bonds that form between a delta plus hydrogen atom in one molecule and a delta minus atom, like oxygen or nitrogen, in another molecule. Lastly, we have van der Waals forces. These are very weak, temporary attractions between molecules caused by random shifts in electron density. The physical properties of molecules are low melting point and boiling point, variable solubility in H2O, poor conductivity, and it can be found as a solid, liquid, or gas.